second years faculty and first years. My name is William Armstrong. My broad-based area of study is transportation technology. I'm a licensed automotive technician by trade. This is my Numeracy lesson plan presentation portion of this project. The area of study or area of focus for this lesson plan, the end goal was to be able to use the vernier caliper. So using a backwards approach in creating my lesson plan, the end goal was to be able to accurately use a vernier caliper, but in deciding how to do that, something I've noticed as a common theme through conversations and discussions is how what is simple to us is out of this world to our students. So starting with the basics seemed like a really appropriate place to begin. Before we even get into imperial versus metric versus why there's different systems, I thought it was important to understand why we even needed to have the importance of accurate tools for measurement. So my lesson plan was going to begin with understanding what a tolerance is, understanding what a specification is, and understanding why the level of accuracy is so important. For the experienced individuals here that have used this kind of equipment, I'm sure you're all aware that the difference of 1/1000th of an inch makes the difference if something fits or not, whether something breaks or not. And that is exactly how I would begin this conversation with the class, is asking them, where else can you think the level of accuracy is important? Cardinal points with directions, money. One simple degree off walking in a direction can lead you to a totally different city over a long enough period of time. Pardon me. Beginning with the basics and understanding the decimal system and measurement in general is applicable to what I've found was pretty well every single trade. From the automotive industry, as I've already explained, measuring internal engine components down to simple brake components, to accurate machine work, CNC, CAD, CAM, and actually running mills or lathes. Woodworking, maybe not using a vernier caliper, but if you can understand the decimal system, fractions start to go hand in hand with that. That's a totally different lesson. That takes another period of time to explain how to convert that. I wanted to start with something simple. Moving the decimal over, or something simple to us that could be explained to them, moving the decimal over, explaining how 1 inch, half of that is 1/2. Well, expressed as a decimal, what's half of 1? 0.5. Okay, half an inch. What's half of half? A quarter, money, 0.250. Starting simple and explaining how decimals work was really where I wanted this lesson to focus. The end goal is for them to read a vernier, but if they have an understanding of decimals and just how to move that over, that's a really good way to start to include STEM, science, technology, engineering, and math, into our lesson plans. After an explanation of how decimals work, it was going to move into a demonstration on the vernier caliper. The importance of having delicate care of a tool that has precise measurements is important to all trades, because being able to use this precise tool and having delicate care for it transfers to woodworking and craftsmanship and the dangerous tools there, into the precise use of equipment in millwright shops such as lathes and end mills. In hospitality, the different knives and stoves and burner tops. And hairstyling, where we have hot curling irons and scissors. It's not just about the number with this lesson, it is about the level of care and practice you need to use in using all equipment. As discussed, something so simple and trivial to us, numbers, can be really intimidating to them. So beginning the lesson, as discussed, with explaining fractions and decimals is a really easy transferable skill that will be discussed throughout most of these skilled trades, and that's part of the reason why I chose this as a part of my numeracy lesson plan. Being able to use precise measurement tools, being able to use fractions and count decimals is going to be applicable to the automotive tech stream, to manufacturing tech stream, and construction tech stream, just to name a few. And communication technology, architectural design, CAD/CAM programs, understanding the importance of making sure all the walls you're building in the program are accurate and correct. So after a discussion of different terminology and a discussion on how to use fractions and decimals and our Dewey Decimal System, which would all be a blackboard or whiteboard given lesson, because it's difficult to watch a video or a PowerPoint on this kind of stuff. Being able to do it on the board in real time, call upon students to come up and do examples on the board. Everybody learns a different way, but a lot of people learn by doing, and you can't do it if you're just watching it on the screen. Another important part of this numeracy lesson plan and why it is so important is they need to not just be able, one of the learning outcomes is not just being able to write down the number. We can see half inch 500 thousandths. We can see a quarter inch 250 thousandths. What if I need to write that down? What does that number mean? I'm not an engineer, I don't write blueprints, and I have no idea what service information is going to look like to me. I need to be able to read different values fractionally and as a decimal, and I need to be able to write out the numerical written version of that. So if I write down on an examination paper or some kind of assessment, write a decimal of 327 thousandths of an inch, what does that look like as a decimal? That transferable skill is going to be applicable not just through science, technology, engineering, and math tech streams, but that's also going to apply to math, science, physics, classrooms, academic, applied, college level, or university level. So following an explanation of the Dewey Decimal System, following an explanation of different terminology, decimals, and fractions, we move on to the demonstration of the vernier caliper tool, which is the end goal learning outcome of this class. Here we have 3 different types of vernier calipers. This larger one is typically used for measuring brake drums. This is a more commonly used vernier caliper where it measures in both fractions and in decimals, which is really important in the trade because we got to be able to go from fractions to decimals and vice versa. Starting simply, I wanted to focus mostly on decimals, but moving from 0.500 to 1/2 is a concept that is built over time through more lessons. This type of vernier caliper is the same as this one, but it measures in a digital scale. This is a demonstration on the activity that the students would be required to do. Understanding the different parts of the vernier, its care, how to take care of it, and the importance of zeroing it would already have been discussed during the in-class lesson, where as previously mentioned, it would be a discussion on the black or whiteboard where they would understand how to actually read, the scale and interpret the numbers. This is just a demonstration on the activity they are required to do. This screw down here is how we're able to move this dial to accurately zero the gauge. This one has already been zeroed. So the activity would require students to measure the outside diameter between these 2 jaws of objects outlined in the worksheet, which is provided with as an attachment with the lesson plan. They would then be required to measure objects with the inside jaws of this vernier caliper, accurately take a measurement on the decimal scale. Following that, they would be required to take measurements in depth using this plunger here at the end of the vernier caliper.
In the lesson plan, I have outlined different objects such as wrenches and sockets as objects commonly found in an automotive shop classroom where they would be able to take these measurements. What I really like about this numeracy lesson plan, as we have discussed, is it starts with the basics. Moving into the later grades, 11 and 12, because this is for grade 10 tasks, they would move into measuring pistons, cylinder bores, lifters, just as an example to name a few, where a final semester project working backwards would be disassemble an engine, take these measurements, find if they are within the specification, and know the tolerance, what is allowed, of these parts, just as discussed in the lesson or theory portion of this class. That is why we are starting from the bottom here and moving up. So, to give a demonstration of this activity, what the students would be required is as follows. Locate an object as described in the lesson plan, such as this socket here. This is a 36mm impact socket, 1/2-inch drive. They would first be required to find the tool and make sure it is zeroed, which this one has already been done. Next, opening up the jaws, gently clamp around the outside diameter of the object described, and using the lock nut located here, they would take the measurement, read it, and then they would be required to fill it out on their worksheet. As mentioned earlier, how to actually read this scale and interpret these numbers would have been discussed as a class activity in the classroom, where students would be called upon to help answer questions and write down answers on the board together as a class to understand how to interpret decimals and how to read this scale. Following the readings of the outside diameter of the objects described, next they would be required to take inside diameter measurements using these jaws here. Just as before, make sure the tool is zeroed. If you're off by even 1/1000th of an inch, that is going to skew everything. That is the level of importance of accuracy and understanding your tolerances and specifications. Using this socket here, students would be required to open the jaws just as before, gently, until we are within the object that we are wishing to measure the inside diameter of. Using the lock nut, it's backwards. Using the lock nut, we've tightened it down and we have taken the inside measurement of this socket. Following that, we would record the value received and move on to depth. As a note, there are multiple objects that are going to have to be required, labeled and identified in the worksheet that they are going to have to take these measurements of, because practice makes perfect. For depth, it is a similar practice. You're going to zero your tool, open the tool to approximately the length of the object we are wishing to measure, insert it, and move it down to just where it stops, lock the tool, and then we have the depth of the tool described. Record our values, lock it down. In the lesson, we previously discussed the importance of taking care of these tools and the care. So we put it back where it belongs, close it down, and return it to the tool crib where it had been signed out.
So, following the activity or the demonstration of the activity on how to use a vernier caliper, we can see how we can use numbers, numeracy, and the automotive tech stream. We have also discussed its importance with STEM and how it can be applicable to other trades. Thank you very much for listening to my presentation.